welcome everybody to this informed session that has been organized by the NetApp on NetApp team. Today's webinar is entitled How NetApp IT Manages Unstructured Data with StorageGRID. As you know, StorageGRID is one of the NetApp products. Presenting today, we have Ken Lee and Ram Kodialbail. I'm not sure, Ram, if I'm pronouncing your surname correctly, but you can beat me up later on.
Perfect, we got it right.
So both Ken and Ram are senior IT storage engineers at NetApp. So they know our solutions, and they've been working with them for a long time. This webinar is actually recorded, and we actually will forward the links to the recordings after this session. Also, if you want to ask questions, you can post them on the chat, or you can raise your hand and you can ask directly. Mary Jo, anything else to add? Or?
Sure. Hi, everyone. This is Mary Jo LeBlanc. I'm part of the NetApp on NetApp program. I'm joined today with Deanna Vargas from our team. So a couple of things I just want you to be aware of. With the COVID-19 and everyone working from home, we have made a change in how we deliver these webinars. We pre-record them so that we ensure that we've kind of eliminated as many technical glitches as possible. So how we'll conduct today is, well, first of all, we're going to start with a poll. We want to find out, sorry, excuse me, how familiar everyone is with StorageGRID. And Deanna, I don't know, do I need to stop sharing for you to hit the poll? Oh, there you go, poll's up. We're going to start with this poll just to kind of gauge how many folks on the line today. So if you could just take a minute to yes or no to see how familiar you are with StorageGRID. And then from there, then we're going to have Ken, we'll have a couple, Ken Lee will do a kickoff, talk a little bit about our organization, our history with StorageGRID, as well as what we have today, and then go into the NetApp authentication, NetApp Authentic, I forget, but we'll get there. And then Ron will have a section on how they have done S3 as a service, or on our service catalog on ServiceNow as part of our Cloud One environment. So it looks like about 80% are. You can go ahead and share the results, Steve, if you want to push the results. So we have about 80% that are familiar with it and 20% that are not. So with that said, I'm going to ask Ken, if you don't mind, could you just quickly give everyone on the call here a bit about what StorageGRID is, and then we'll start the first section of the recording.
Sure. Yeah, this is just a quick overview, just so that everybody understand what's the why you would use StorageGRID as opposed to the other type of storage like block or NFS. So, for StorageGRID, each piece of data that comes in, like a file or something, is an object. So storage, object storage allows you to store large numbers or large amounts of unstructured data. For example, the unstructured data are usually photos, songs, videos, backups and archive data. And object storage is also used mostly for static data that doesn't change very often. But as we move into the future for object storage, that is slightly changing. When the hardware becomes more powerful, there's a small change toward more transactional, because other companies are looking at that to see if they could leverage that. There is no file systems or folders to help you organize the data, so each piece of the data has a unique identifier that can be used to directly locate that data. So each object includes the data itself, internal and user-defined metadata, and then again, that unique ID that is able to directly locate that data without going through any structure or hierarchy or INOs and all that stuff. Okay?
All right. Thanks, Ken. Appreciate that. Any questions about that before we start the actual recordings in the webinar? Okay, let's start then.
This presentation will highlight a use case within NetApp IT that consumes most of the features that exist in StorageGRID. Before we get to that story, here is a quick overview of corporate IT at NetApp. We are currently running around 100+ petabytes of storage. That storage includes FAS, AFF, StorageGRID, E-Series, SolidFire, and HCI storage. Recently, we completed our 7-mode filer decommission project. Therefore, we are entirely on cluster ONTAP. We have over 450 storage controllers and over 5,000 servers. Cloud1 is our private cloud service using Kubernetes/OpenShift. Customer-1 is where we partner with our product teams to test and roll out new features in our production environment. We also do POC products like Keystone. This is a little history of NetApp IT StorageGRID Journey. We started back in May of 2015, version 10, as part of a Customer-1 initiative. Our first application for StorageGRID was for archiving to meet SOX compliance. It was NetBackup, AutoVault, and StorageGRID. Prior to StorageGRID, SOX was going to tape using NetBackup. After running tapes parallel with StorageGRID, in October, we removed the tape library and went tapeless. The next large application was ActiveIQ flat files. Within 6 months, it was up to 600 terabytes. As you can see, the type of data that we started with is archive data and then static data. In May of 2018, when version 11 was released, that had a big change and much needed improvements. That is when an application named Authenticated File Upload, NavFoo, decided to use StorageGRID as their backend storage because it fit their needs, which I will go into later in later slides. We created a new DMC StorageGRID and put NavFoo in it, and they went live in October of 2018. Because of that success, we POC and created a grid in Amsterdam in March of 2019, and then the final project concluded with leveraging AWS S3 in Sydney. This is what our StorageGRID environment looks like. We have 3 production grids. The first one is our corp grid, which is only accessible from internal NetApp network. It spans 3 site locations, 11 nodes in Sunnyvale, California, 24 nodes in RTP, that's Raleigh, North Carolina, and 20 nodes in Hillsboro, Oregon. We are using VM gateways as their endpoint for StorageGRID. For the internal DMZ, it is a 2-site grid because Sunnyvale is no longer considered a data center. This gives us 10 nodes in RTP and 9 nodes in HIO. Instead of using VM gateways, we started using F5 load balancer for endpoint access to the grid. Amsterdam is a smaller grid. It is a single site grid and is also in the DMZ with just 6 physical nodes. It is used for, no, it is using the F5 load balancer there too. NetApp Authenticated File Upload, NavFoo. This is the application which drove our StorageGRID growth and direction. The goal of NavFoo was to allow customers to upload any type of file with a maximum size of 800 gigabytes, and eventually becoming the premier method of choice for all file uploads. The list of requirements is shown here, which I will go through each individually, was met by using StorageGRID. The application wanted the customers to upload support files without having to install any type of software or installing plugins for their browser. Within the browser, it must support cores so that the application can move to different domains within the browser as needed. To be able to do multi-part upload or running parallel upload sessions to maximize upload performance, it has to have multi-site protection so that when one site goes down, the application still works. To be able to transfer data from one storage grid to another. And finally, to support notification services. You might have seen this already, the application GUI interface. This meets the first two requirements, the browser and cross-origin resource sharing, CORS capable. Customer no longer need to install any uploading software. CORS support became available in version 11 of StorageGRID. We installed version 11 the day it was released, and at the time, I don't think any of our customers were using CORS because CORS didn't work. The StorageGRID developers used our environment to figure out what was missing from CORS and gave us an internal patch so that the project can continue. Although we still have our old options, some of which might no longer exist, but as you can see, NavFoo beats all the older methods and meet all the objectives for the project because of StorageGRID. For a large file data transfer, to get good upload performance, you either have to have a large network pipe or you run parallel upload sessions. There is usually a high cost associated with large networks, and we wanted to avoid that. Multi-part upload is very important to our application team. With multi-part upload, everything is taken care of. Breaking a single file into multiple chunks, upload those chunks in parallel from the client, auto startability for chunks failure, and then putting the chunks back into a single object within StorageGRID. This is the upload testing results prior to go live. For the smaller files, even if they didn't meet the SLA of 180 megabits per second, we were more concerned about the large files, which is pretty good. Okay. In the earlier slides, it shows that we started with the core storage grid. That grid is in the internal core network, and our security folks would not allow us to use the grid for external facing activities. Therefore, we had to create a DMZ group, but the problem was our support team was in the core network. The platform service Cloudmera in StorageGRID allow us to move the uploaded files that was inside our DMZ grid into our core grid with just using StorageGRID configurations. This is what the NavFoo application looks like. It is using an F5 global server load balancer, the GLSP endpoints to either HIO or RTP. StorageGRID in the DMZ will transfer the data to corp grid and from there to the engineering domain. There are two items that this slide is not saying. One is that Amsterdam grid came later. After the successful implementation in the US, we were still getting complaints of slow uploads from our European customer because of the distance to the United States. We put a grid in Amsterdam to try to fix that problem. Some of you experts in StorageGRID might question, why did we not just extend the DMZ grid to include Amsterdam as a site? Well, NetApp has a very small network pipe from Amsterdam to US. We were not worried about how much time it would take for the file to get from Amsterdam to the United States, because if our support team needed that data right away, they can always log into Amsterdam and see the data. What we were worried about is the metadata. As you grow the grid to a lot more nodes, each site have to have metadata about all of the other nodes. That chattiness of small packets of metadata going back and forth on a low bandwidth network could cause services within StorageGRID to queue up and cause issues for the site or the grid itself. Therefore, we chose to create a separate grid, a separate independent grid. The go live of this was well received, and some of our European customers were very happy. I said some, but I will come back to that later. The second item that this slide did not show is another of the requirements that the application needed, which is notification service. As you can guess, when a file is uploaded, how do we know the multi-part upload, or for that matter, the file reached the corp storage grid? The old method would be for the program to consistently check to see if the file is available, but that is not very efficient. This is where notification comes in. We configure a bucket to send notification to Amazon Simple Notification Service, SNS, so that when a file completed its upload, a message is sent to AWS. SNS will push the message to any subscriber, which will be a NavFoo program, and then will activate the next process. This way, the program does not need to periodically check or poll for the status of an upload file. So there you have it. Most of the features available from StorageGRID used by NavFoo. Getting back to my comment about some of our customers in Europe, we're still not happy because unless they were near Amsterdam, upload speed can be very slow, and we are back to the original problem. Because the backend storage is object storage, NavFoo should be able to connect to any object storage with little or no modification. This is where AWS S3 object storage comes in. What we did was spin up a AWS S3 in Sydney and pointed the application endpoints to AWS and start uploading files into AWS S3. In the US, we also spin up an S3 instance as a target object storage. In this way, we would use the AWS network backbone to move the uploaded file from Sydney to AWS East, and from AWS East, we use CloudSync to move the files into our core storage grid. Within AWS, we don't leave the data there. Once it has been moved, we delete the files and keep costs down. Now we can scale this AWS solution to get closer to our largest customer if needed, with minimal changes to the application. Phase 1 of the project was to create an application using StorageGRID, which is object storage. Phase 2 of the project was to expand the application to Amsterdam or our European customers. Phase 3 was to find a method to be able to provide the same upload speed regardless of location to a certain extent, because the storage backend is StorageGRID object store. NavFoo should be able to connect to AWS S3 storage with little or no modifications. When ONTAP object storage is available, and if it becomes available for Cloud ONTAP, we, as Customer 1, will look into replacing AWS S3 with Cloud ONTAP S3. That concludes my presentation.
Hello, everyone. This is Kodialbail, Storage Engineer, NetApp IT. So as Customer 1, we make every effort possible to use our own products and services, hopefully well before our customers do. In some rare situations, we may end up in a position where all the bells and whistles may not be readily available to meet our service requirements. Today, I'll share with you our work at building some automation around StorageGRID. You might wonder what took us down that path. Okay, so let's do the next. The effort was driven by our service requirements of Cloud1. Cloud1 is our internal cloud and DevOps platform. Cloud1 provides the cloud services, automation, and CI/CD release models that our application development team needs to build cloud-native applications. No cloud-native application is complete without object storage. As with everything else on Cloud1, users will expect self-service, hence the need for automation. If you would like to know more about Cloud1, we have several webinars, blogs, and podcasts on our site. As you can see in the image block of this slide, at the core, we have ServiceNow, Ansible Tower, and Azure Repos. A user submits the request on ServiceNow Service Portal. The modules and the playbooks are on Azure Repos. Ansible Tower has the projects and templates for orchestration, which means that our object storage automation had to be using Ansible. Okay, so the automation workflow, as you can see here, is fairly simple at this point. It should create the user groups, create the bucket, and finally email the keys and the gateway details back to the requester. So StorageGRID supports S3 and Swift protocols, which is great for us. That gives us REST API at our disposal. As you may already know, with REST API, you can use any programming language and treat server objects as resources that can be created or destroyed using HTTP methods. By the way, note that REST API is supported natively on all of our current generation of products and services. As you can see on this slide, StorageGRID supports AWS S3 specifications. Okay. Given our requirements and starter blocks, we definitely need Ansible modules. When we started working on this project, official modules for StorageGRID did not exist. We could not use AWS S3 modules except for the S3 bucket module. We've considered other standard modules such as URI, but that would result in a complex playbook without a clean desired state configuration. So writing our own custom module was the logical option. So we have Ansible 2.9, we had to use Python. We've decided to use Ansible fetch URL. This is part of the standard Ansible build. And then since we have REST API, StorageGRID API is available for us. And as I mentioned before, the S3 bucket module from the Ansible development branch was the only module we could consume. Okay, and part of the standard module build, we've used these Ansible Modulators. Okay. So we end up building or developing 4 modules. One to create and delete tenant accounts, one to delete user accounts with the required group configuration, one module to get the bucket creation timestamp, and finally the module to report bucket usage. Okay, and yeah, the standard variable files in case you want to automate across several grids. Right? So next few set of slides, we'll take a peek at each of these modules that we have developed. Okay, first comes the tenant create module, a set of input that's required, and some are optional. So as I mentioned, the desired state, you can set the state to present or absent. And once that is provided to the module, it will give you the output back with the change set to OK or failure. And this is the output for you. Okay, creates the tenant if it's successful, provides all the details for this is just the output of the module. Don't have the complete playbook. We will cover that at the end of this presentation. So right now we'll just look at the function of each module. Right? What happens if the tenant already exists? That condition has to be taken care of too, right? So it gives you a message saying that such and such tenant exists and nothing to be done. Moving on to the next one, removing or deleting the tenant. Again, just the name and the state. You can say present or absent, and then it'll, in this case, since we want to delete, the state has to be set to absent, and the resulting action will be performed. Output from this module, deleting the tenant is successful. In case the tenant does not exist, no action will be performed. Okay, and that's shown here in this slide. Going on to the next module, which is creating the user. The same module could be used to create and delete the users. So similar set of input variables required for the user module, which, as you can tell, the user full name, user login, user password, which is required, and finally the state. And the output will be the user details and the gateway specific for that grid and change state. Okay. And here's the output from that module. When the user does not exist, it creates the user and gives you the output. Okay. And if for the condition where the user already exists, no action or no change, right? So here you note that app1 user already exists. And moving on to deleting the user. Pretty much the same set of input, except the state needs to be absent in this case, right? Okay. So removes the user. And the successfully removed here. And in case the user does not exist, no change. Change state is set to false as expected. Finally, bucket create. Remember, I mentioned that we use the S3 bucket part of the build, the standard. Well, this is not the standard module. The standard module could not be used here as is because a chargeback function was, or a chargeback feature was not implemented in StorageGRID. But this fix was available in the development build of the Ansible S3 bucket module. So that's what we used. And just to make sure that we know which model that we're using, I've named it as S3 bucket dev. Okay. So all other features are supported except for that chargeback. So, okay. Creating bucket, success. And this is because, remember I mentioned S3 APIs are supported by StorageGRID, so we could use the S3 bucket development module. Okay, bucket created, and for these next module that we wrote, that was to get the usage information. Here's the output of that. It's pretty simple. You just specify either the tenant or the bucket as one of the values, and it will give you the usage information. So if you specify the tenant, it will list out all the buckets under that tenant. And if you specify just the bucket information, it will just return the usage for that bucket. So we get the final playbook, which will create the users, the groups, required groups, and the buckets. Finally, also generating the S3 keys for the user and emailing it back to the user. Now, if you were to do this manually, the traditional way where the user would submit a ticket and then the operations lead would reach back to the requester, find out the application details and all that, going back and forth, it might take them a minimum of 30 minutes to step through each page on the admin GUI of StorageGRID to you need to go to one pane to create the user, and then the groups before that, generate the S3 keys for the user, and finally creating the buckets. And then you gather all this information and you have to provide it back to the customer, right? So that would take, as I mentioned, it would take anywhere between 30 minutes to a couple of hours, because you may have to go back and forth with the requester to gather all the details, and there may be delay involved. But as you can see from the screen, what could have taken you at least 30 minutes is done in a matter of 30 to 14 seconds, right? So that's a big advantage here. So it's definitely automation helping us here, right? Okay, and so with all that work that we did, you don't have to worry about any of that, because as I mentioned earlier, when we started off, there were no modules available, but now just last month, the official modules from NetApp are available now. So it can create and delete tenant accounts. It can create, modify the grid admin group also, and the admin users, just like we are doing. It goes beyond that, and you can also set the DNS servers, NTP servers, set the grid regions, which our custom modules are not capable of doing. In addition, we have our own S3 bucket and S3 keys management modules. So it's so much easier for you to take up any automation project, right? So all of this is available on our netapp.io site. There are several blogs and instruction on fetching the collections for StorageGRID. And I believe you can, there's also a Slack channel if you want any assistance, okay? So that's all I have to share with you guys today. So if you have any questions, please let us know. Thank you very much.
All right, thanks Ram and Ken for doing those recordings and being on today to answer any questions. Are there any questions around what Ram has described? Again, you can do the chat, you can do the Q&A window. All right, very good. So thank you for attending. We appreciate it. Right now, we are planning next month to come in and talk about our how we developed an infrastructure as a service offering, as well as a container as a service. As Ram mentioned earlier, it's all off of our what we call our Cloud-1 platform. It's part of our self-service portal. So we'll come in and present that. There's I'll be perfectly honest, there's not a lot of NetApp products in play there. But I'm going to try to figure out how we can bring in and talk about the NetApp products that are behind the scenes, so that you can understand like what we are running and behind all of that automation in our private cloud, as well as where do we use the public cloud. So so just keep a track of the invitations that come out. You can find those invitations on netappit.com. It is where we post all of our use cases. You'll see a webinar tab there. You'll get all the information on not only the recordings from this webinar and the presentation, but from previous webinars as well. We also have our blogs, our white papers, infographics, and down at the bottom, if you go down there, you'll see kind of our what I call the use case in a slide. So check out netappit.com. It's available to anyone. You can share it with your customers. You can share it with your grandmother if you like. It's totally optional. But yeah, so we'll be back again next month. Until then, please stay safe, stay healthy, enjoy your summer. Elias, do you have any parting words for everyone today?
No, yeah, thank you very much for attending today. And as Mary Jo said, be safe, and you know where you can get the recordings. So you've got the link here on the slide. That was it. Thank you very much, Ken and Ram, for doing these recordings. And yeah, be safe.
Okay.
Thank you very much.
Thanks, everyone.
See you.
Bye-bye.
Bye-bye.
Bye-bye.